Everybody, thanks so much for joining my session today. As the slide says, my name's Todd Golding, and I'm a Partner Solutions Architect at AWS, and I'm part of a team that's called the SaaS Factory, and that team works with organizations that are in various stages of building or delivering and optimizing SaaS solutions on top of AWS. And we've been working with these organizations for quite a while now, and along the way, we've sort of seen more and more need for more prescriptive content and solutions that can really help accelerate adoption of SaaS on AWS. And so what we've done along the way is create a bunch of prescriptive solutions and prescriptive content that really can give you a head start when you're looking to build or maybe even modernize a SaaS solution on top of AWS. And so that's really the focus and the goal of our session today, is to look at a handful of these specific prescriptive solutions and really give you a view of the range of different options that we've provided, with the idea that this would give you a sense of maybe how or if some of these prescriptive solutions might be a really good match for the solutions that you're building. Now, we're going to look at three of these today, and as part of looking at these, obviously, because we're going to look at three and we're in sort of a condensed format here, we're not going to be able to go super deep on each solution. But the goal here is to expose you to enough of the architecture of each of these solutions that you can then go away and dig into the actual reference content behind all of this. Download the code, install it, read the docs, and so on. So I'll give you links at the end, and the idea is that you can then take the sort of the concepts that we outline here and then go dig in more deeply where it fits for you. Now, it's a 300 level session, so we're mostly going to be looking at the architecture of these solutions. We're not going to be looking maybe at the underlying code. But we should sort of meet the technical bar of a 300 session for you. So I'm hoping that the architectural details here will be enough for you. Now, before we dig into each of these architectures, it's important to highlight here that each of these solutions follows a common theme. Like on the right-hand side, for example, you'll see all of these solutions have what we would call a shared services domain. And over on this right-hand side are all those things that are common to any SaaS implementation that you might build. So here you'll see onboarding and tenant management and user management. These are all the horizontal services that you would need to build into any solution. And at the top here, you see we have an admin application. That admin application is really meant to be the management experience for all of those services that are in that shared services domain. And we include that because we really want you to get a sense of what it would mean to build a management experience for your SaaS environment that manages all of your tenants. Now, on the left-hand side, you'll see we have what I call the application domain. And here's where most of what we're going to talk about is on this left-hand side here, right? Which is how do I actually build a SaaS application, and how does it look different if I'm building it maybe with EKS versus in a serverless SaaS model or an ECS or some other pattern. So for our purposes, we're really going to think about what are the different patterns that can appear in this left-hand side and how do they interact with these shared services potentially. I've also included DevOps here because what you'll see across some of these solutions, and you'll see that this is a pattern for us going forward, we're reaching more and more into that DevOps space because what we're seeing is different tenant tiers and different configurations have a real strong influence on that DevOps experience. But this is kind of like a common landscape to all of these and a common theme that you'll see across all of these solutions. Now, the three solutions that we're going to look at today fall into sort of three different categories, and certainly we'll be adding to the menu of these options. But today we're going to look at an EKS reference architecture, and this architecture basically takes all those concepts of tenant isolation and data partitioning and identity that we talk about in SaaS environments and implements them in an EKS architecture. So we'll look at the very specific things you have to do inside of EKS to bring multi-tenancy to life in that environment. We're also going to look at serverless SaaS. Serverless SaaS here, again, same notions, tenant isolation, data partitioning, etc. But now we'll look at that through the lens of a serverless experience and what it would mean to build this with Lambda and so on. And then the last one we'll look at is a sort of unique in this category in that we'll look at AWS SaaS Boost, which is really meant to target a lift and shift experience, which is how can we take an existing monolith or an existing application that isn't SaaS today and give you a prescriptive solution that lets you lift your existing code into a SaaS environment with as little friction as possible. And here the emphasis is on really creating as much of a point and click experience for you as we can. Okay, so let's start with EKS, right? Like I said here, EKS brings some very specific sort of considerations that we have to think about when we're building a SaaS architecture. And if we look at kind of the outer edge of the architecture, we'll see like what the application experience is across this in terms of the different web applications that we include in this solution. So if you start on the left-hand side, you'll see we have a landing page. And this is essentially where a new customer would come in, find your product, say, oh, I'm interested, register and onboard to your product, indicating the plan and the other bits that they're signing up for. And then once they're signed up for that system, they'll get an email and so on. And then they'll actually go to the SaaS application, which you see in the middle. And we've created a really sort of simple SaaS application here that just sort of highlights the end-to-end experience. So you can see it from the web app all the way through the back end. And we've also included it because it really shows you how identity works really well in an EKS environment here. It uses Cognito, and we look at how Cognito ends up routing your traffic to the individual components of your EKS SaaS architecture. And then on the right-hand side, finally, is this admin application. This is that application that sits on top of those shared services and lets us manage tenants. It lets us manage users. It lets us essentially manage the global configuration of our SaaS environment. Now, under the hood of those applications is an EKS cluster. And the EKS cluster is broken down in that left and right sort of model that we talked about at the beginning. On the left-hand side are the microservices that we deploy for our tenants. So we've got a product and order with DynamoDB here. And on the right-hand side, you'll see we have the shared services. So registration, user, tenant, etc. That are the ones that we talked about at the beginning, where they'll manage the onboarding of a tenant. They'll manage just the sort of management experience through the admin console of the tenant. And you'll see these use Cognito and DynamoDB as well. But all of this is running inside of an EKS cluster. Now, if we look at that environment a little more closely and say, okay, we've downloaded the EKS reference solution, we've run the installation for it, what does it actually provision for us? Well, you'll see it creates a multi-AZ VPC for you. Very much a high availability, high scalability sort of default sort of pattern that is really common on AWS. And then within that, you'll see that our EKS cluster and our shared services, registration, tenant management, user management, all get provisioned in this environment well, right? Remember, these are the shared services, and these are the services we need before any tenant gets into our system. And along with this, you'll see that user management is using Cognito to manage the user state. You'll see tenant management is using DynamoDB, and then we've got a code pipeline here as well. The code pipeline will essentially manage a lot of our provisioning and configuration experience. But this is the baseline environment that gets created when you set up the EKS environment. And then as you onboard tenants, we have to look at what gets provisioned when an actual tenant gets introduced into this environment. So here you'll see same multi-AZ environment, same VPC. This is all the same cluster that we had for our shared services experience, except now as each new tenant comes in, we're actually going to provision infrastructure for that tenant. And here in EKS, you have a number of options, right? And when we built this EKS reference architecture, we could have used a pooled model where the containers were shared, but that would have some isolation considerations, and so we'd have to think about that. We could have done a cluster per tenant, but what we thought was a good compromise here was a namespace per tenant model. So here, as you create a new tenant and as you introduce them into the environment, you'll see that a tenant namespace gets provisioned, and now the microservices for that namespace get created. And the nice part of this is that now for this tenant, I could actually have a different scaling profile. So if this is a basic tier tenant, I might have one set of scaling rules for this. And now when I onboard the next tenant, this could be a premium tenant, and they could be provisioned and scaled differently. But as we'll see as we look forward here, this namespace model is also core to our overall tenant isolation model. But this is the data and the configuration that gets created each time you introduce a new tenant. Now, let's drill into that a little bit more and talk a little bit more about what that provisioning experience looks like. So here on the right-hand side, you'll see an environment where we have a couple of tenants already. And in this environment, you'll see we're using an Nginx ingress controller. Certainly when we created this ingress controller was a big part of discussion for us. Could we use different tools? There's a lot of options here. Could we have used API Gateway here? We settled on the Nginx ingress controller, but we think this is an area that's going to be pretty fluid and an area that we'll continue to explore as we go forward. But in this case, the Nginx controller gets our requests and routes them to our individual tenant namespaces. So in here we have already 2 tenants that have been onboarded. So now when we introduce a third tenant, we hit the registration service. The registration service kicks off the code pipeline, and then that runs this kubectl set of commands here that are going to configure lots of the moving parts of our tenant's environment. So here you'll see we'll set up the IAM roles, we'll actually create the namespace, we'll set up IAM roles, we'll set up all the bits that are needed to make this namespace work in a multi-tenant sort of construct. And then also you'll see as part of this that each microservice then also has a separate YAML, and this is where we're allowed to configure the setup of each microservice, the scaling profile of each microservice independently. And this is also where we set up the routing from Ingress. So this is where we'll create the Ingress resource that is used to route tenants to their individual namespaces, specifically to a microservice in that namespace. Now the Ingress resource here model is probably worth looking at a little more closely. So you'll see here how this works essentially. When you hit Route 53, you'll see that we have a subdomain. And then as that subdomain flows through the Ingress controller, it will actually look at the origin in that of that incoming request and figure out that it belongs to tenant 1 or tenant 2. And then because we configured these individual microservices with Ingress resources, we've essentially connected the Ingress controller to its target microservice in a given tenant. We can then have the traffic routed specifically to those individual microservices. And to me, this, no matter which sort of approach you take when you're building an EKS-based solution here in SaaS, this is an area you're going to have to focus and spend a lot of time on. What is the right routing strategy for your tenant environment? Now, if we look at isolation inside of this, how do we sort of ensure that tenants are isolated? Yes, we've done a namespace per tenant, but what do we do within those namespaces to be sure that we don't have any tenant crossing a boundary we don't expect? So if we say, oh, we have these 2 separate namespaces now when we provision these environments, one thing we can do to sort of prevent cross-tenant access is to introduce these pod security policies. And these pod security policies really make sure that there is no cross-tenant, cross-namespace sort of interaction here. And that gives us one level of tenant isolation. These microservices also interact with data, in this case DynamoDB in this example. And so now as these microservices go out to interact with, for example, in this case, an order table, and in this case, it's siloed for each tenant, meaning each tenant has its own table. Now we have to have IAM policies associated with our interactions with these policies. So you'll see in this example how we use IAM policies to constrain a tenant's views so that a tenant in one namespace can't access the order table of a tenant in another namespace. We also have a product table that uses what we call a pooled model of storage here, where all the tenant data is in a single table. And in this scenario, we also have to have an IAM policy, but now instead of at a table level, we'll actually look at an item level. We'll use leading key conditions inside of IAM to control a tenant's access to the individual items inside the DynamoDB table. So this is kind of all the moving parts that we can look at today on EKS. There's an entire reInvent talk on this as well that's out there. And again, look at the reference solution. But hopefully this gives you a feel for some of the bits that are there. Let's look now at the serverless SaaS solution that we've created and how it works, and maybe how it looks a little different than the EKS solution. So let's start here by looking at the EKS, the serverless SaaS high-level architecture. And when you look at this architecture, and if you've looked at any serverless web application architecture, it looks very much like this, right? We've got a web application running in a bucket on the outer edge. It's coming through an API gateway, and then it's interacting with some microservices, and those microservices might be interacting with storage. What's unique here, though, is as you drill into these bits and as you look at this in more detail, you'll actually find out that the identity experience influences what happens here at the API gateway, and how we'll introduce authorizers. You'll look at how we'll use usage plans to throttle at the API gateway. So there's multi-tenant influence on that edge as we come in. And then as we get inside the individual services here, like the order service and the product service, there's all kinds of multi-tenant goodness in the way that we implement those microservices to deal with logging and metrics and token management, all to sort of hide the details of multi-tenancy away from our microservice developers. And of course, we still have in this environment in serverless SaaS these shared services that we talked about at the beginning. So here again, onboarding, user management, tenant management. And in here, you'll even see we have these provisioning services that are responsible for setting up and configuring different serverless tenant profiles in different tiers. We also have the same application on the top of this. So we have the admin application. It's authenticated. So that same theme here of having an application that is the admin experience shows up in this environment. Now, one of the things that's here uniquely in the serverless SaaS environment that isn't in EKS, it'll probably find it its way into more and more of our solutions, is this unique footprint driven by the tier of each individual tenant. So to just drill into that a little more, so if you look here on the left-hand side, you'll see we have 3 tenants all running against an order and a product microservice. And they're running in this pooled model. They're sharing the infrastructure here across this solution. And now, though, tenant 4 is some premium tier tenant. They, for some reason, warranted having their own microservices. So in this environment, running right alongside our pooled tenants is a siloed deployment for a specific tenant. And our onboarding process essentially takes care of all this. So when I onboard, if I choose basic tenant, I will go into the pooled environment. If I choose one of these platinum or premium sort of tenants, I'll get my own siloed sort of environment. And this is to handle the realities that for some tenants, they will demand they will demand their own isolation. They will demand solutions that ensure that they don't have noisy neighbor problems, and so on. So any number of different business factors might have you offer a different experience to one type of tenant versus another. And then finally here, you'll see tenant 5, and I really just included tenant 5 here to highlight the fact that as in each one of these siloed tenants onboard, our provisioning experience here has to now create and provision the microservices for that tenant. So you can see here that now our DevOps chain and our deployment chain has to look at the tier of our tenant and decide, are you just going to drop into this pooled configuration, or do we have to actually provision resources for you as part of this siloed experience? The other thing here is that we have to think about how we build multi-tenant microservices. And in this reference architecture, we really wanted to highlight some best practices here around what it means to write a really good multi-tenant serverless microservice. So here you'll see we have our product and our order service. They both accept this JSON web token, this JOT, and that comes from identity. You can look at our other content to see how you get that, but that JOT is enriched with the tenant identity, the tenant's role, all this metadata about the tenant that really helps us have that tenant context at our fingertips. And then when that JOT comes in, these services will often have to take actions that will require tenant context. And our goal here is to say, let's hide all of the mechanics of that away from developers. So when they need to do something that relies on tenant context, there's a library or something else that will take care of that for them and sort of hide away the details of multi-tenancy. So in this case, you'll see that we have this Lambda layer that's running here. And in this Lambda layer, we've got a set of helper services. We've got a logging manager so that when you go to log a message, you just say log, you pass in the token context. It figures out who the tenant is using the token manager that will turn the JOT into a tenant ID and inject that tenant into your log messages. Same thing with metrics. And then here you also see what we call a token vending machine. This token vending machine is used for your isolation story to go out and get credentials, get a token that is specific to you as a tenant. So as I'm processing a request, I go out to STS, I get you a token, and that token is then used to access downstream resources like data and so on to ensure that we aren't crossing tenant boundaries. The key thing here is that this is all deployed in a layer and it's running in the same process as the Lambda functions here, right? This isn't a separate sort of Lambda service or a separate microservice that's doing all of this. This is all running in the context of and in the process of these functions. If we carve this out as a separate microservice, it makes it too chatty, it has latency problems. So we're always encouraging people, yes, write all these helpers, but don't put them in separate microservices. Put them in libraries or models or whatever the language construct that works for you so that they are shared by your tenants. I'm sorry, shared by your microservices. And in this case, we're using layers in Lambda, which are perfect for this. So if I update something about logging, I can update it once, deploy a new layer, and then all my microservices will pick up that change. Finally, one of the other things we look at in the serverless environment where we make heavy use of the API gateway is how can we have different experiences for tiers at the outer edge, so throttling and security and other bits as enforced by the API gateway. So here we see you have a couple of tenants coming in, they're hitting the API gateway, and one of the things we'll add here is an authorizer, and that authorizer will essentially look at that JWT token that comes in, find out what your role is as a tenant, who you are, and then only enable paths or routes in the API gateway that are valid for you as a tenant. So we get an extra sort of goodness, an extra sort of protection here to, at the edge, verify that you aren't going any further than you're supposed to. You also see here that we've implemented strategies for implementing throttling strategies on a tier by tier basis. So you'll see we'll have like a basic tier API key, and we'll have an advanced tier API key. And those will have usage plans attached to them so that a basic tier tenant somehow can't undermine the experience of an advanced or a platinum tier tenant. And this is really a key concept where you'll see us do more and more of this across our reference solutions. But hopefully this gives you a sense of kind of what happens inside of the serverless SaaS environment. Again, lots more moving parts, but you get a sense of what we've built here. The last piece we're going to look at is AWS SaaS Boost. And like I said, a SaaS Boost is really targeting a slightly different experience than what we do in the reference architectures. With the reference architectures, we really were just trying to say, here's a sample implementation, go grab it and use it and learn from it as best you can. With SaaS Boost, we're really trying to create a full experience of somebody taking an existing application and moving it as quickly as they can to a SaaS offering. So if you can imagine, you have customers with their running their one-off version, separately managed, separately operated, and now you're trying to migrate as quickly as you can to a SaaS offering. People are looking for some way to say, how can I do that without rewriting my application? And that's exactly what SaaS Boost is targeting, right? It's trying to say, with a few clicks and a few actions on your part, you can essentially set up this environment, move your application into this experience, and begin to offer it to your customers as a multi-tenant solution. So you'll drop it into an environment where we already provide you billing and we provide you analytics and we deal with the automation of the onboarding and all those bits. So it's a very prescriptive environment that is ready to sort of take your application and move it as quickly as it can into a SaaS model. Now, if you look at what the developer experience of that looks like, so again, this is an open source solution. It's meant to be all the code in it. You sort of can get it and modify it and do whatever you want with it. So you download that to your environment, and you then essentially run an installation, which will set it all up in your AWS account. It'll provision all the resources you need, set up all the core infrastructure that's needed to run SaaS Boost, and then you go out and actually set up your application. So here you'll set up, tell us what kind of app you have, what kind of database it uses, does it need a file system? You'll configure all the attributes of your application, and then you'll give us your application. You'll actually go out and you'll need to containerize your application. This is hopefully, if you've got a monolith, you can just create a containerized version of it and then upload that container to the SaaS Boost environment. And once that's in SaaS Boost, we know what your app is configured like. We have this container with your application. Now we're ready to just start provisioning tenants and setting them up. So now we can start provisioning tenants and really get the goodness of SaaS here and let SaaS Boost take care of provisioning and all the moving parts of getting a new tenant introduced. So you go from these sort of high friction world where each tenant has their own environment to this universe where if you want to add 100 new tenants tomorrow, all the automation and all the billing and all the other moving parts are there to make that just work for you. And then once that's all set up, we also offer sort of management view into this. So there's analytics that are viewing this, there's a provisioning view into this that lets you see how tenant environments are provisioning, and so on. So we look at what gets created in this. This is, again, the shared services theme we talked at the beginning. You can imagine that SaaS Boost relies on a bunch of shared services to make all this work. So here you'll see it has an admin application running in React. That's hitting API gateway, and then hitting the same old shared services here. This has got a richer set of shared services maybe than some of the other environments. It's more metrics, it's got a richer billing implementation, it's got more analytics in it, so there's more moving parts in this than maybe the other reference architectures. And then on the right-hand side, you'll see that we've broken out sort of billing and analytics on the right-hand side. And we call those out separately because even though they're in the box with SaaS Boost, they still require some work on part of your application. Like, we don't know how you're going to want to bill. we don't know which analytics are going to be valuable to you. So you still have to instrument all that into your own application. You'll also see that that application through the API gateway can interact with these shared services. So for example, if you have onboarding in your application, it could trigger onboarding from your application as well. But these are like the foundational services that are created. Then when you actually set up and provision tenants, what gets provisioned under the hood? Well, in this model, because we're lift and shifting you in, we're running a full stack silo environment. Every tenant gets their own environment. So each tenant is going to have their own VPC, and it's going to be a multi-AZ VPC, and it will be running your application in an ECS cluster, running on Fargate here. And then these will be actually sized based on the tier of your tenant. So you might deploy one tenant in a basic tier with one set of sizing, and another tenant in an advanced tier with a different sort of scaling profile. And then we've included database and file system here. These depend on how you've configured your application. Which RDS database? Are you using SQL Server or MySQL or one of the other databases that Aurora, for example, and are using a file system is really common as people migrating needing EFS or FSX. So you'll tell us what those bits are. So these are sort of placeholders for what will land in your tenant environments. Now, I said that I would share some links with you, and here they are. There's obviously all three of these items have links, and again, take you out to the repos, and you can essentially download these solutions and bring them into your environment and begin to really poke at them and go to the next level of detail that we really couldn't get here. So a few takeaways. Well, hopefully you can see, first of all, shared services just common to all of these solutions. So all of our reference solutions are there, and this probably means however you build your solution, you're going to need to build a similar layer into your application. The other thing is silo and pool, like you saw how it showed up differently, especially in the serverless solution that you had. Like the models that you need to deploy could very much affect your architecture. Are you going to use a namespace per tenant? Are you going to use a cluster per tenant? Are you going to use pooled? Are you going to have some mix of those things? You have to think about all that as you think about which architectural model you're going to implement. And definitely factor in the fact that DevOps is going to be part of your architecture, right? You can see how tiering reaches all the way out into the DevOps footprint of your solution, and you want to be inclusive of that from the beginning. You definitely want to have this, we talked about this administration experience, and we give you a sort of a hint of what that looks like by giving you an app that lets you manage tenants and so on. We mostly want you to sort of realize that's an important piece of the experience, and that should be part of your experience, even if you decide to build your own application. And then is serverless right for you? Is EKS the right architecture for you? Is it a mix of those things? I don't know. The idea here was to expose you to a range of options, look at the realities of your business, and then figure out which one of these or which combination of these might be a good fit for your model. And then the last thing here is that these are all meant to be sort of open source out there in the community, ready for you to consume. And our goal really is to provide these to you and then continue to involve them yourself, but also get your feedback to tell us how you'd like them to evolve to really meet the real world sort of scenarios that you're facing with your solutions. And that's it. I know we rushed through this, and I know we didn't go as deeply maybe as you wanted into these, because I sort of opted here for going a little wider to give you more exposure to the options rather than going deep. But I hope you got enough out of it that you could get a sense for whether or not any of these solutions might be a good fit for you in helping you figure out how to build and deliver your SaaS solution on top of AWS. Thank you so much.